Welcome to this tutorial. Kindly subscribe so that every time we post a new video you'll be the first one to see it. Okay, today we want to get a solution to exact differential equations. I want to see how we solve exact differential equations. From my previous tutorial, I gave out how we test exactness of a differential equation. So if you have not checked on that, kindly look at the link above there so that you may get to check on how we test exactness of differential equations. Now let's see how we solve them. So there are some things that you need to know. So these are the steps of solving an exact DE. So first, you set a function u to be integral of m plus a given a function of h, y h function of y. Then after that, you solve for du dy, and after getting the du dy, you equate it to n. This is in the effort of getting the derivative of this function h of y. Then after that, if you want to get hy, you basically get integral of that function. And step 4, then you substitute the function of h, which is the function of y, so that you'll be able to get the solution. So that's basically the overview of what we are doing when we are solving an exact DE. Now, let's look at an example. Solve this particular example here. It's a good one for practice. So we have this. So what we need to know, this is our m, this is our n. Okay, so that we get the function of course, if you have this and you are doing exam, you have to check whether the equation is exact. You have to check whether the equation is exact, and this is from our previous tutorial. So if you've got on this, kindly check on the previous tutorial. You'll see how we check for exactness. So in this case, this kind of the equation given here is exact. So what we need to do now to solve it, you can get that function of u. So we take m dx, this is our m dx, plus hy. Integrating this bit here for m, you'll find this is true. So I'm just expanding this bit. So we have that. The next step is to get the du partial derivative of u in respect to y, and you'll find that this is now the solution that we are getting. Next is to equate the partial derivative of u in respect to y to n. Remember n from our equation. So when you equate it, you can see most of things here are similar. That implies that the derivative of h, you'll get it is negative hy. Now, if I want to get hy, the function of hy, I'll need just to integrate the derivative of hy, and I'll get negative 4y squared. Then now let us go back and substitute hy in our solution, in our u function. So when you substitute that, you basically get that. And therefore the solution that for this DE exactly is basically that. It's basically that. That's the reason from the start I told you that the function of u is actually the solution. It's actually the solution. So if you have a question on this bit, kindly leave a comment down there. I'll be able to respond to you as soon as possible. And even if you have a question that you also need me to look at, you can even leave it at the comment. Okay, so that is it for today. Kindly subscribe for more tutorials. Thank you.